We're here in San Diego, and we've recently moved into a new location. And what this location is all about is customizing a facility to mirror the scientific process that we need to go through to create new products. Over the last several years, the finances have really been a significant challenge for the company. The company did borrow $160 million, and in the end, one of the proudest achievements that we have in 2012 is that on April 2nd, we were able to repay all of our debt and become a company financed the way that's really you need to be for a small, growing technology company. We're equity financed today, and that's the basis on which we're looking to move forward. 2 years ago, we really turned all of our attention onto the industrial enzymes business that we are today. We had 70 people at the time, and in the last 2 years, we've grown to 100 people. We see continued growth. Today, we have 9 marketed enzyme products. We market them at the animal feed industry. We market them at the grain processing industry, which would include corn ethanol. We also market them at the oil and gas industry. The magic about what we are is that we have a unique way of creating high performance enzymes. And those enzymes are created from nature. About 15 years ago, we began our bioprospecting, which was going around the globe, taking environmental samples from harsh environments, whether it's the Sakhalin Island off the coast of Russia or volcanic vents at the bottom of the Mediterranean Sea. And the material that we discovered there included organisms. And what we were able to do is isolate the enzymes those organisms were already creating in order that when we went to create an enzyme useful in an industrial process that was low pH or very high temperature, we could really start with that naturally evolved ability that these organisms had to create the type of robustness that's required for what is effectively a protein to survive in an industrial environment. For example, our fuelzyme, alpha amylase, is the enzyme that we sell to the corn ethanol industry. And the material that forms the basis of that enzyme came from undersea volcanic vents from the Mediterranean as well as the coast of California. We then had to effectively shuffle the genetic material in a very specific way to make the performance characteristics greater than any individual mutant that we had. And we took that enzyme and applied it into a process, the corn ethanol industry, that benefits from having an enzyme that is highly thermostable, so it can survive in very high temperature environments, but also can resist very low pH environments. If you think about mashing the corn, you effectively end up with a peanut butter that you need to get to flow through the pipes of the plant. And so amongst other things, what our enzyme does is it helps to liquefy this very viscous material so it will flow through the pipes, and also to make some of the sugars available in a different form by breaking down the starches that's more readily accessible to the downstream parts of the corn ethanol process. Today we sell a product through a partner, DuPont, called Phyzyme phytase. It's a phytase enzyme, and phytase enzymes have been used in the poultry industry for a long period of time. What we created was a different kind of phytase enzyme. Fundamentally, what a phytase does is, rather than the traditional process where in a ton of animal feed you would put a 25-pound bag of rock phosphorus, much of which goes through the animal and effectively becomes pollution, what we were able to do is take a phytase enzyme which effectively unlocks the phosphorus that's already in the grains that the poultry is eating. And we were able to make an enzyme that allows the food to be maximally digested by poultry. And so it reduces the environmental impact, but it also improves the outcome for the farmer raising the poultry. We also market them to the oil and gas industry, where we have an enzyme that's used in the fracking process of oil wells. It's effectively taking out acids and some other chemicals that can be damaging to the environment as well as damaging to the oil well itself, and replacing them with what is effectively a harmless protein to perform one of the key roles within the fracking process. So when we designed the building, we started with the processes and the technology that we practice, but the way that we bring products to market requires many different disciplines to come together, to interact, to think about how do you solve what are effectively some very challenging problems that industry faces today. What we wanted to do is create an atmosphere where people could interact openly in order to allow all of those disciplines to come together. We have a very open space. It's designed that way because the company is a collaborative company. It requires skills coming together in ways that you can't map out in an organizational diagram. What you really need is for people to interact daily and really come together to form the kind of new ideas that will become the new products.
This news update was brought to you by San Diego Biotechnology Connection, a career building and media relations service and the top source for news about the thriving San Diego biotech sector.